So in this video we are going to see about clustering using rapid manner. So that is what we are going to see. So for that we are going to take the iris dataset, and in the iris dataset, as you all know, there are three different labels. One is setosa, versicolor and virginica. So these are the three different labels which we have, right? And then we have four different parameters or arguments. So it is sepal length, sepal width, petal length, petal width. So these are the four different attributes which you have, and all are numeric attributes. So going back to the design, so now you know about how your iris dataset will look like. So you are taking the iris dataset, and now say if you are clustering based on all the attributes, then you could just connect it to a clustering, any of the clustering methods which are available, and you can look over to the performance of how the clusters are being formed. Say if you want to restrict the outputs or the number of the clusters, or you have to restrict, say, select a subset of attributes, okay, which you have to use, and you have to remove the other attributes, then you need to go for special operators, which we have already seen before in one of our experiments, that is select attributes. So you have to select this attribute, okay. So you are clicking on to select attributes, and here you don't want all, instead you want subset, okay. And here you will be selecting these two, so say A3 and A4, okay. Now one issue with this particular data set is that when we look over to the data set, saw like A1, A2, A3, A4. So somebody who is new to this particular data set may not be able to understand what is this A1, A2, A3, A4. So as we know, and as we have seen this for so many times, we know what those attributes are. So what we could do is that we could use a operator called rename operator, which will help us to rename the attributes, okay. So what we could do is we could select A3 and we could give petal length and say we need one more. So we will edit here, we will go to A4 and we will change it as petal width. So this is what we could do, and we could apply, okay. So now we have selected only two attributes, okay, and its names are nothing but petal length and petal width. So this is what actually we have seen. Now what we have to do is that now we need to apply the clustering. So in order to apply clustering, you could just type in the operator section, you can type clustering. So there are so many different clustering options or operators available here. So in that we are going to understand, or we are going to try the k-means clustering, which is the simplest one. So we are using the k-means clustering. So once we have this k-means clustering, connect this here, okay. So connect your clustering, and now what you have to understand is that here there are so many parameters which has been displayed, and in that we have already told you that the k is going to be set as 2. The maximum runs, let it be 10 itself, and we know that the attributes, we have already seen the attributes here are all numeric attributes. So we need to get the Euclidean distance measure. So which one will be the Euclidean distance measure? It is nothing but the numeric distance measure. So when you select numeric distance measure, you have all this. In that we will use the Euclidean distance measure. So that's all is the selection which is required here at this particular thing. And now what you have to do is that, so when you click over here, now we have to actually select it to the performance, sorry. So we need to know the performance of our clustering, because then only we'll be able to understand how many clusters has been formed and everything. So performance, when we look over to performance, there are so many operators available. In that we need to basically look over to the performance which is related to cluster. So we have cluster count, cluster distance, density, so many. So here we are using the distance measure, so we are using the cluster performance, distance performance. So when you click over here, you can understand that it is clustering model, and here when you click over it, it is clustered set, okay. So we need to map it correctly to the performance. So when you click over here, it is example set, and here it is clustering model. So you know that this is clustering model and this is performance cluster model. So which two has to be connected? These two has to be connected. And what about this one? This one is a clustered set, that is from your example set. And when you look over here, you could also see that now the A3 and the A1, Okay, its name has been changed to petal length and petal width. Okay, so understand its name has been changed because we have renamed it and we have removed other attributes A1 and A2. So that is what you have to understand by these two particular steps. That is what we have basically done by those two steps. Now, this is the example, the clustered set, and this is the example, the performance. Okay, so what you have to do is that you need to connect it here. So this connection has to be perfect, and then if you want, you can actually connect this original thing to the result. Okay, and then you could try connecting the performance. So this gives you the performance of what will be the performance vectors, that means the values exactly, and this gives you the performance vector for the example set. Yeah, now this gives you the performance for the clustered model. So you have used k-means clustering, so how will it look like? So this is what we have to do in this particular simple example. So these two steps are basically not required if you are not restricting to a certain number of attributes, but say normally when we do it for an application, we will have to restrict it to a certain attribute. So that's why in order to help you to understand, there are operations like that, this has been shown. Okay, now we will run this. So you can go to the design. See here, everything is tick, 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 tick. So everything is fine and perfect. Now we are going to the results. Now you could see that there are two clusters which are, so only two clusters are shown here. Okay, so cluster 0 is giving you 51 values and cluster 1 99 values. So this is the clustering model results, and your select attributes, you have selected only these two. Okay, and this is your original example set data. So this is exactly the example set data, and now this is the example set for clustering. So you could see that, so how it is actually being clustered. So this in the cluster 1, which all are the IDs which are available, what all are the values. Okay, in the cluster 0 and cluster 1, it is shown, all this 150 values has been shown here properly. Now when you go back to the statistics, you could see that what is the statistics for the, what is the maximum value, what is the average, what is the petal width, everything is basically displayed here. Okay, so in Virginica, Setosa, so how many are there, so all those things has been shown here. Okay, now if you go to the visualization and if you take, say, cluster, the scatter plot, you could see that how basically the clusters are basically formed. Okay, so these are the two things. So you could see this cluster scatter matrix. Yeah, so you could see that how it is basically distributed. So this is the petal width and this is the petal length. So it is very clearly given how it is basically done. Okay, so all this kind of all this can be very clearly understood by this particular what is that these type of and let me see, line area, the scatter 3D. Yes, so you could see how it is seen. So there are different varieties in which you could actually understand how it is basically done. So this is all about, so when you get the values, it is very important for you to understand how the data is, how the data is basically. And there is something called centroid table, which gives you the complete information about, okay, in petal length, okay, what is a cluster 0, what are this is the centroid coordinates, and for the petal width, okay, the centroid coordinates. So it is very important for you to understand this, because you will get a clear idea about what is a cluster 1 centroid, what is a cluster 2, cluster 0 and 1 here, that is nothing but 1 and 2. So 0 and 1, the centroid. So you will have a clear idea about two different centroids. So this information, this inference from the clustering output is very important, because simply clustering by using the operators, it's not it is not required. But once you get the cluster output or the clustering output, understanding or inferring from the clustering output, how do you infer from the output, it's very important. So if you get a clustering output, it is very interesting to understand that which all clusters are there, which all are the values in which all clusters. Okay, everything could be seen here, and then you could also plot it and see how the cluster looks like. So you could also, here also you could actually change it, and you could try different ways to understand how the clusters are basically. So there are 2 clusters, that's all it shows here. Then it shows you the full cluster. So how many IDs, which all IDs are there in the 0, and which all IDs are there in cluster 1, everything could be very clearly understood. And then you could get a complete idea about how many items on each and every cluster. So cluster 1 has got more values. Then there is a cluster table which gives you the information about the cluster 0 and the cluster 1. So where the centroid x and y coordinate, where the the centroid values lies, and you can plot it and see how it looks like. So all these informations are basically available in the clustering. So simply getting the output is not important, but it is very important for you to understand how each and what do you infer from the output. So you could see that the average of both is this one, the distance of the cluster is this one. So all these things are basically given here. You will be able to understand by this outputs. So it's very simple and very important to understand this. So hope you understood the small example, okay, which we have seen. So thank you so much. So hope this will be, you will be able to use this knowledge which you got from here for any of your further applications. Thank you so much. So in this example, we are going to see about the k-means clustering, but with a special operator called aggregate. Okay, so this aggregate operation will basically help you to have a better visualization of your output. So you'll be able to do a better inference from the output. So that is what we are going to do. So as we have always seen this, so this is the iris data set, where you have 3 different options here, right? So 3 different classes here basically, and you do have sepal length, width. This is a sepal length, sepal width, petal length, petal width. So now you are going to work on the iris data set. So you are straight away moving over to here. So as in the last one, we are not going to do any. We are going to take all the attributes. So I told you, right? So we could directly select all the attributes here. So once you did that, after clustering only we are going to work on here. So if in your application, if you have to work after your operation, so you could basically use this technique. So I'm just simply going to use an attribute called operator called aggregate. So in aggregate, so understand this is the cluster model, and this is the clustered set. So I'm going to connect this cluster set to this aggregate. Okay, so this is the aggregate function. So here which all has to be taken into consideration while visualization. So I'm going to select these 4, that is sepal length, width, sepal width, petal length, petal width for display. Okay, so this is what I'm taking. Okay, and now what am I going to do is I'm going to reorder the attributes. So I want to have my analysis based on a particular order. Okay, so I have some attribute called reorder. Okay, I have one attribute called reorder attribute. So in the reorder attribute, this is the example output, and this is the example set input. So this is what you have to basically connect. So this is just the original one. So this is like exactly your data set, what it is. So that you don't have to use. So this is the one. So when you are connecting it, make sure that you should make sense while you are connecting. So otherwise there is no use in it. Now when you go here, I'm going to decide the order. So it's user defined. So I'm going to select the order. Say I'm just taking the reverse order. So I want petal width, then I want petal length, then I want sepal width, then I want sepal length. So I'm just reordering it, and this is the order wherein I want the results to be seen, right? So I have reordered it. Now I'm going to sort it, a simple sort function. So all this we have seen before also. In one of our examples we have already seen this. So here this is the reorder example output, and this is the example input. So this has to be connected. Okay, so always understand how to connect it. Okay, so here in the sorting order, okay, in the sorting I'm just going to give, I want my results to be in based on the values of petal width, okay, and that too in the increasing order of the petal width. Okay, so I have 4 attributes. In that I want my results to be sorted in the order of petal width, and that too in the increasing petal width order. Okay, so that is what I have. Now in order for, say, if any new person is coming who don't know about the data set, then you could actually add one more thing, that is nothing but the rename. You have already seen this. So this is the output and this is the input, so connect here. So this is where you have to connect, and here you can give say A4 as the petal width. Okay, and now you can add the rest here. Okay, so as the petal length, and you can add 2 more entries. So here A2 is your sepal. Here any order you could give, I am just giving this order, that's all. Petal width, and here A1 is the sepal length. So this is what we are giving. So this is the order with which we have given. So now what has to be the output? So we have to so what we will do is, so we want, this is the clustering model, right? So we want to see the model. Okay, so this is one of the results which we basically look for. Okay, model. Now what about this aggregate? Yeah, the aggregate output you could see, that you could connect. And then what else you can see? The other one is the output of your rename operation. That means you have reordered it, you have sorted it, and that output in the renamed way you have to output. So these are the different ways of output. So this is not mandatory, but you know, this clustered output and this output is basically mandatory. So this is what it is. So I don't think there is any error for this. So we could just run this. So when you run this, you could see the output. So now it is about the inference. Okay, how do you infer from the output? Okay, so here when you see this output, so this is the output of the rename operation. See here, this is the output of the rename operation. This is the model output operation, and this is just your data set, and this is the clustering, you know, which you have done. Okay, so these are the different outputs which you have got. So when you see here, these are the 3 different outputs which you have. Okay, so you have your this is your clustering model. Okay, and this output, when you see this output, so this is nothing but the data table. Okay, the data table which consists of all the aggregated data table. Okay, and this is your rename output. These are the 3 different outputs which you have. So when you go back to the results, okay, so this is the output of the rename. So in the design, when you see, once again you have reordered the attributes. How did you reorder the attributes? So you have defined the order in A4, A3, A2, A1. So this is how you have renamed it. Okay, then you have sorted it according to A4, and that has been renamed, right? So when you see this particular results, you could see all the 4 attributes are there in the order A4, A3, then A2, A1. So it is in that particular order, right? And you have renamed it with petal width, petal length, sepal width, sepal length. So that is also done. So now what is the sorting which has been done? For the petal width, A4 has to be sorted in the increasing order. So when you see the values here, it has been sorted in the increasing order. So this is what you have done. Okay, and this is your clustering. Okay, how you have actually clustered this particular data. So it has been actually clustered into 4 different clusters. Okay, so in each of the clusters, what all are the values which we have? So totally we have 150. So everything when you add together, it will be 150, right? And this is your data set which you have. So this is what it's all about. So when you go here, when you go to this statistics, you will be able to see the minimum, the maximum, what is the average, and everything you could understand. So these are all the places where you need to basically see, you can you have options here. Yeah, so this is the place where you have to basically infer the or understand the data more about it. So when you click here for the visualization, you could see the kind of the data spread. Okay, so how each cluster of the data has been spread, so that could be understood here very clearly. So you can use any different type of any different types of so you could use a color group here, I guess. So if you use the color group, you could see here that as well. So but you know, it is actually beautifully shown by this by this a scatter plot. So if it is scatter plot, you will be able to understand the spread of the data very clearly, where each cluster of the data basically lies. Okay, so this is your petal length, which is having a very low average, and here you could understand that all of them are almost together, but there is petal. Yeah, here it is actually, yeah, the color is actually given. So you could have your, one second, if you're not giving any color, it will just show you single color. That's all it is. Okay, so that is how you will be able to see it, so this is just for the petal width. Then you could see for the petal, width and everything, each and everything you could actually see here. Okay, and so anyone which you want. So how the spread of each particular data is, you'll be able to see it. And yeah, so you have actually selected here, and if you want to select more, okay, you could use that as well. So it will show you all the three. Now say if you want to select all the 4, okay, that is also possible. So if you see here, you will be able to very clearly understand how the spread of all the values here, and that is also possible, right? So here, so these are the spread of the data, and this one based on something else. So if you want all the columns based on petal length, how will it look like? Okay, so all these values, and here the petal length. Okay, how will it look like? Okay, how each values are basically related to each other. So all those understanding, all this could be seen and understood by this particular graphs. So this is what you have to understand. So once you get the output, it is very important for you to infer it. So that is one simple example. So this is basically, we saw this particular example to understand that a lot of visualization is possible after the clustering. So before the clustering also we have seen, after the clustering also it is possible. So these are the 2 examples which helps you to understand that. Okay, so hope you will be this example will be helpful for your project. Okay, so keep all this in mind, because you will have to use all this nitty-gritties when you are applying for your major project. Thank you so much. So in this video, we are going to see about the how to use the agglomerative clustering, right? So hope you all know that agglomerative and divisive clustering basically comes under hierarchical clustering, right? And they uses dendrograms to show how the data will look like. And agglomerative is basically bottom-up approach, and divisive is basically top-down approach. So this is what we know. So for this here, we are using a data set called replay. Okay, so don't worry about what this replay is. Replay is a very simple data set which has got 2 different attributes. So each of the attributes are basically the combination of Gaussian distribution. So Gaussian means basically, so normal means, so the normal distribution, okay, whatever be the mean, it's a combination of both the values are basically some mean values, and that too taken from the what is that, the Gaussian distribution, right? So this is what it is. So we will just try forming a simple agglomerative clustering. So this is our data set which we have, right? Now what we have to do is that, yeah, we are going to the clustering. In the clustering, we do have different type of clustering available. In that, we are going to take agglomerative clustering, and now we need to know how to so this is the output of the replay, and this is the clustering example set. So this is how we need to apply it, right? And this is the model, and this is nothing but the example set. Yes, so we need to see the output of the model. So that's all we are going to do. We are not trying to make it any complex. So this is what we are going to do. So here, when you click over to hit, there are different links available. So in that, we are just taking the normal link, single link, and here we do have different measures available. Okay, so if you want, basically you could take a numeric measure, so you will be using the Euclidean one. That's all. So once we run this, so you could see that the number of the clusters which is given is 499. Okay, so you could also see that it is very clearly written. It's a hierarchical cluster model, okay, with the number of clusters 499. So this is the description which you could see, and here you could see the example set, right? So all those things you could see. Now when you go back to the cluster model, okay, when you go to the folder view, okay, when you go to the folder view, you could very clearly understand that it comes in the form of a cluster. okay, sorry, hierarchy. Okay, so here there is a main hierarchy for then 497, then 490. It just goes like that. So it basically looks like a hierarchical model, okay, which you could see. Now, if you want a better view of this, you could. So this is the hierarchical model which you could see, right? Now, if you want to see the graph, yeah, this is possible. So when you scroll down to the left and right, you could see all the root nodes and everything. Yeah, this is the other one which I really wanted to show you, the dendrogram, right? So this dendrogram basically helps you to understand the kind of the hierarchical clustering. So basically, you know that in this agglomerative clustering, so this is a bottom up clustering. So you could see that even the smallest, how each and every clusters is combined together to form the biggest cluster. So all this informations could be seen here by using this description. So this is how the agglomerative clustering will look like. Okay, so hope you understood this. Okay, so this is what I wanted to show you in the agglomerative clustering. So thank you.